How can I prove and apply the Pythagorean theorem and its converse? So in that, there's a lot. The Pythagorean theorem is this idea that we discovered, a man named Pythagoras discovered, I think his name was Pythagoras, he discovered thousands of years ago. Basically what he found is that the longest side, or the hypotenuse, which is another word, the longest side of a right triangle is, if you square that, it's equal to both of the other two sides squared and added together. So if I called these sides A, B, and C, A squared plus B squared equals C squared when you're dealing with a right triangle. A right triangle is a triangle that has one right angle. The converse is the opposite of that. And what that means is that if I have three sides to a triangle, but I don't know if it's a right triangle or not, it means that I can do A squared plus B squared, and if it equals C squared, then it is a right triangle, and if it doesn't, then it's not. So I can use the converse to determine if a triangle is a right triangle without actually measuring the angles. Proof is kind of what I was talking about in the converse. It's where you prove or you show something. So we're going to show the Pythagorean theorem and how it works. What is the Pythagorean theorem? Let's get more into that. So we have three sides to a right triangle. You have the two legs, which we're going to call A and B. And you have the hypotenuse, which is the longest side. The longest side is the hypotenuse, and it's always across from the right angle. So here's the right angle, and across from it is always going to be your hypotenuse. And so we're going to call that one C. What was discovered back by Pythagoras for the Pythagorean theorem is that if you put a square with side length A and a square with side length B, if you had little tiles to represent the area, you could basically take those tiles out of here, move them here, and they would fill exactly a square with side length C. So the area would be the same, and that's the Pythagorean theorem, that A squared plus B squared equals C squared. So how do I use this? You're going to be given a triangle sometimes. This is just a general application, is where you have one side is 3, one side is 4. So they give us the two legs, A squared and B squared. And we need to figure out they give us A and B, and we need to figure out what C is. We know it's a right triangle because it's this symbol tells us. So we do A squared plus B squared equals C squared. We know that A is 3 and B is 4, or you could reverse these. It doesn't make a difference. So 3 squared plus 4 squared equals C squared. So 9, 3 squared is 9, 4 squared is 16. So 9 plus 16 equals C squared. 9 plus 16 is 25, so 25 equals C squared. Now I take the square root of 25 and the square root of C squared. Square root of C squared is C. Square root of 25 is 5. So this side length is equal to 5. Here we have a right triangle, but this time we're missing one of the legs. So we're going to call that B. We know one leg is 10, and we know the hypotenuse is 15. So when we do A squared plus B squared equals C squared, we put 10 squared plus B squared equals 15 squared. Then we can find that we know that 10 squared is equal to 100, and 15 squared is equal to 225 because we either used a calculator or a reference chart. B squared is going to stay as B squared. I can algebraically then do 100 plus B squared minus 100 equals 25 minus 100. And I've taken 100 away from both sides. I'm then left with B squared equals 125. Now I can take the square root. The square root of B squared equals the square root of 125, which is approximately, I used a calculator, is approximately 11 and 1800ths. So B is going to approximately be 11 and 1800ths. And this is how you would solve for a missing side in a right triangle. Here's the converse of this type of problem. The converse is where you're given three side lengths. For example, 6, 8, and 10. And you substitute them in. We always know that the longest side is C. The hypotenuse is always the longest side. So whenever you're given three side lengths, the longest one will always be substituted in for C squared. So I substitute in 10 for C, and I do 10 squared is 100. I substitute in 8 for B. I do 8 squared is 64, and I substitute in 6 for A, and 6 squared is 36. When I add 36 and 64, that equals 100, which is equal to 100. So not only is this answer right, but it's also a right triangle. So this A triangle with side length of 6, 8, and 10 would be a right triangle, as we proved using the converse of the Pythagorean theorem. Here's an example where it doesn't work. 7, 8, and 13. If I substitute in 7 for A, I get 7 squared. 8 for B, I get 8 squared. And 13 for C is 13 squared. I can use a calculator or a reference chart and figure out that 7 squared is 49, 8 squared is 64, and 13 squared is 169. 49 plus 64 equals 113, which does not equal 169. Because of that, it is not, these three side lengths would not form a right triangle. And so now we go back to the beginning and we've talked about how I can prove and apply the Pythagorean theorem and its converse. I'll include another additional proof in the description section and a link for that. It's a little more complicated, but this is a kind of a simple proof.